Hi everyone, my name is Claytone Sikasote. I'm excited to be talking to you today about our paper titled BembaSpeech, a speech recognition corpus for the Bemba language. This is a joint work with Antonios Anastasopoulos. The motivation for creating the BembaSpeech dataset arises from the lack of linguistic resources, both textual and speech, for Zambian languages. In this case, we wanted to build a speech dataset that could serve the need to build speech recognition systems in Bemba language. Now, Bemba, also referred to as Ichibemba, is a Bantu language principally spoken in Zambia by over 30% of the population. It is considered to be a written language, but also low-resourced language. It has 5 vowels and 19 consonants. Its syllable structure is characteristically open and is of 4 many types: V, CV, NCV, and NCGV. The writing system of Bemba language is based on Latin script. To describe the BembaSpeech dataset, it consists of 24 hours of read speech in Bemba language. It has in total 14,438 utterances, 17 speakers, 9 males and 8 females. The dataset is split into 3 fixed subsets: the training set, development set, and test set. And among the subsets, there is no speaker overlap. The dataset has all audio files encoded in .wav format with a single track mono recording with a sample rate of 16 kilohertz. The League Ikuma mobile application was used to create or to record the speech from text that was tokenized at sentence level. The text in the dataset was sourced from diverse publicly available sources and resources. This includes literature books, YouTube movie transcripts, radio and TV shows transcripts, as well as various online resources. The dataset is preprocessed to ensure data accuracy, particularly to ensure that every utterance in the dataset has or matches a respective transcript. The dataset is publicly available to the research community under the Creative Commons BY-NC-ND 4.0 license. To ascertain the usefulness of the BembaSpeech corpus, we conducted experiments to build an end-to-end BembaSpeech model using the DeepSpeech model version 0.82. The dataset that we used in the experiments is a 17 hours subset of the BembaSpeech dataset. For the baseline model, we trained the DeepSpeech from scratch using default parameters except for batch sizes. There was no improvement to the performance of the model. The word error rate that was achieved was 100%. In a quest to improve the performance of the model, we explored cross-lingual transfer learning. In this particular case, we fine-tuned the pre-trained DeepSpeech English model on the dataset. This improved the word error rate from 100% to 71.21%. We also explored the effect of adding the language model to the fine-tuned model. This was done to see if we could improve the model from 71.21%. In this experiment, we considered two sets of language models. The first set included language models denoted as LM1, which were created from the text that was sourced from transcripts, particularly train and dev set text. The second set of language models, denoted as LM2, it included Bemba text from transcripts with an inclusion of Bemba text from the JW300. For each set, we explored 3-gram, 4-gram, and 5-gram language models. Adding the LM1 to the acoustic model improved the word error rate from 71.21% to at least 54.78%. While adding the LM2 to the acoustic model equally improved the word error rate from 71.21% to at least 55.65%. Interestingly enough, no significant change was observed by the inclusion of Bemba text from the JW300. The best model for all our experiment was the fine-tuned model with an inclusion of a 5-gram language model with text from the transcripts that achieved 54.78% word error rate and 17.05% character error rate. In conclusion, we present to the research community the BembaSpeech ASR dataset. To the best of our knowledge, this is the first linguistic resource for any Zambian language. We have also built the end-to-end Bemba ASR model using DeepSpeech on the 17 hours Corpus subset. Our model achieves a word error rate of 54.78%. The results show that the corpus can be used for building ASR systems for Bemba language. For the future works, we are interested to improve the results of our model. We are also interested to compare our results with other speech recognition toolkits, considering that in our experiments, we only use the DeepSpeech. We also plan to collect even more data in Bemba, also collect data in the different Bemba varieties as spoken throughout the country of Zambia, as well as other Zambian languages. Thank you very much for your attention. Merci beaucoup. Natotela sana mukwai. Epologila.